Probably unmute my microphone so people can hear me. So this may be a short live stream if there ain't too many people out there. It's getting up towards the end of the week, and most of you guys probably don't have questions. But if you do, just fire away if you're in here with me. I want to solve my Rubik's Cube here real quick, and then I'm just decided I want to factor if nobody has questions. So I have a whole video of me just explaining how to factor. Oh. All right, so I'm gonna solve my Rubik's Cube. Then I'm gonna just do a bunch of factoring because a lot of people struggle with factoring. Once I do about 4 or 5 problems, if I still haven't gotten any questions, I am going to go ahead and just call it a day. Good. All right, so no questions. I'm just going to start by factoring. All right, so I'm going to work some problems out of a college textbook I have. It's out of the appendix. And it's just factoring. Nothing terrible. But you guys struggle with factoring, so I'm going to work a couple problems. So I'm going to start out with a nice, easy, greatest common factor one where you have to factor. It says factor completely. Oh, well, this is factor completely, so let's factor completely. So I have 12x squared minus 48. Whenever you factor, the first thing you want to look for is the greatest common factor or the GCF. So that means you're going to look at each individual term. And then with the individual terms, you're going to see if they have anything in common. My first term here is 12x squared. My second term is 48. They both have a 12 in common. I can factor that out. When I factor it out, I'm basically going to divide each of these terms by my greatest common factor of 12. Well, 12 divided by 12 is 1. This leaves me x squared. Minus, and 48 divided by 12 is 4. All right, so 12 is my greatest common factor, and I factored that out. Now, I see right here, x squared minus 4 is a difference of 2 squares. The difference of 2 squares is a special factor that you should have memorized. It is a squared minus b squared equals a squared minus b squared equals a plus b times a minus b. So in this case, my first thing being squared is my a, which is x. The second thing being squared is 2, because 2 squared is 4. So this term right here factors. We're going to bring my 12 down. It's going to factor to x plus 2, x minus 2, and now you're completely factored. You did a GCF and a special factor, the difference of squares. All right, so that one wasn't terribly bad. Just the greatest common factor and a special factor. So I'm going to work a difference of cubes problem here. This is another special factor. What page did? Give me a second. When I made it full screen, it changed my page on me. Now I gotta find the page with all those factors on it. Can't believe I did that. I'm getting there. absolute value stuff. Rational function stuff. Rational function stuff. Above it should be factor. Still rational function. And I think I'm there yet. Yay, I'm finally there. Okay, so I'm going to do explain kind of a special factor called the difference of cubes. So let me look. Yep, no questions yet. Anybody have any actual questions for me? You're just going to watch me solve, like, work difference of cubes. Since I'm working on that page, let me move my chat over so I can actually see it in case somebody actually asks me a question. All right, so the difference of cubes is a special factor. There's two of them. There's a sum of cubes and a difference of cubes. So it has the form of a cubed minus b cubed equals a minus b, and then a squared plus ab plus b squared. This is the difference of cubes, and the sum of cubes is a cubed plus b cubed equals a plus b, then a squared minus ab plus b squared. I forgot my square up there. All right, so these are two special factors, the sum and difference of squares. The a's, this whole part doesn't change except for the sign, and the easy way to remember the sign is an acronym called SOAP. SOAP stands for same, opposite, always, positive. All right, so same, opposite, always positive, because if you look here, the minus, same, opposite, always positive. If you look here, the plus, same, opposite, always positive. So that's your SOAP. So we're going to use this idea to actually factor sum or difference of cubes, because those are special factors. This is the one that most people struggle with. They don't struggle so much with the difference of squares as they do with the difference of cubes. All right, so let's do a nice easy one. Let's do, why not, y cubed plus 64. Okay, so I already know 64 is 4 cubed. I'm going to show you in the calculator how you can actually find it. So here we are with the calculator turned it on. So we're going to clear it. And what we need to do is we need to figure out right here what is the cube root of 64, because that's what we need to actually do, because then when we cube it, it'll actually give us 64 back. So all you're going to do is you're going to hit, have it on there. I'm looking. I'm going to say the cube root, I'm going to use this fact. The cube root of anything is x to the 1/3 power. I'm going to use that fact in the calculator to make my life easier. So I'm going to do 64, and then I want to do a caret, and I'm going to do 1 divided by 3, which is what I wrote here, because my 64 is right there. So I hit enter, and I get 4. So I actually rewrite this as y cubed plus 4 cubed. I haven't used that calculator in a long time, so from here, I know it's going to be a sum of cubes, so it's going to be same, opposite, always positive, so my first sign will be plus. My a is y, my b is 4, so this factors to y plus 4, y squared minus 4y plus 16, because that's 4 squared. So that's a pretty easy way to factor as well. All right, let me check in on the chat, see if anybody has any questions. No question. Y'all just sitting here watching me factor. So you've seen the sum of cubes, difference of cubes works the same way, and we've seen a GCF and a difference of squares. So let's look at something where we actually factor a trinomial, where we have to actually factor a trinomial. So let me pick a nice pretty one. 13x plus 6 plus 5x squared. Okay, so this is not written in the normal fashion. 13x plus 6 plus 5x squared. What you can actually do is just write it in descending order, putting your x squared first. So I'm going to do 5x squared plus 13x plus 6. Just write it in the way you're used to seeing it. Put your x squared first, your x in the middle, and then your constant at the end. You're allowed to do that because of the commutative property in addition. All right. From here, I'm going to do the AC method. The AC method is based on the idea that I'm going to take my A, my leading coefficient here, multiply it by my constant here, which is going to be 5 times 6, which gives me 30. I'm going to list all the factors of 30. So I get 1, 30, 2, 15, 3, 10, 4, 5, and 6. Now I always like to list it like this because as you're going in order here, eventually it's going to stop. You're going to have to loop back up, and that's when you know you have all your factors. These are all plus or minus. Now, because this is a positive, I know my signs have to be the same. So I'm going to look for some combination of these with the signs being the same. It's going to add up to my middle term, which is 13. That's going to be a positive 3 and a positive 10. I'm going to uncombine, or I'm going to split this middle term in two. So I'm going to have 5x squared plus 10x plus 3x plus 6. So what I did is I split this term in two, and I still have 13x if I actually went back and combined like terms. All right, from here, I'm just going to group. And then I want to factor a GCF out of each term. 5x squared and 10x both have a 5x in common, and this is going to give me x plus 2. 3x and 6 have a 3 in common, and this gives me x plus 2. If it's factorable, these terms will be the same. From here, if I look at this individual term and this individual term, they both have an x plus 2 in it, so I can factor that out as a GCF. And I get my x plus 2, there's my GCF I factor out, and that leaves my 5x plus 3. And now I am fully factored. Pretty straightforward problem to do the AC method of factoring. This is what's nice about this algorithm. You can do it every time, and it will work out as long as it's factorable. That's just about every type of scenario you could see for factoring. So let's go on to, let's find something that connects to calculus. Something a little bit more difficult. Simplify, multiply, divide, better subtract. Hey, let's just do this. We're doing, so I want to add a rational function. So this is pretty straightforward. I want to have 2 over x plus 1 plus 2 over x minus 1, and then plus 1 over x squared minus 1. All right, whenever you do anything with rational functions, your first instinct should be factor anything that factors. And I see that this last denominator factors, so I'm going to rewrite this as 2x plus 1 plus 2x minus 1 plus 1 over x plus 1, x minus 1, because it is a difference of squares, because 1 is a perfect square. All right, from here, I need to make a common denominator. So the way I'm going to do that is I'm going to look here, and I have an x plus 1 in my denominator. I have an x minus 1 in the denominator. I have an x plus 1 and an x minus 1. So my common denominator is going to be the x plus 1, x minus 1. I've looked at this x plus 1 and I'm missing the x minus 1. So I want to multiply by a number 1. So I'm going to do x plus 1 over x plus 1. Because x plus 1 divided by x plus 1 is just 1 times 2. What did I do plus? This one should be minus. Should be minus because it's the plus right here. X plus 1 times, I'm going to look at this one. This one's the x minus 1 plus. This is the x minus 1, so this one should be the x plus 1 divided by x plus 1 times 2 over x minus 1 plus 1 over x plus 1 x minus 1. All right, now when we multiply fractions, we just multiply straight across. So we're going to do that. And I want to get 2 times x minus 1 over x minus 1 x plus 1 plus 2 times x plus 1 all over x plus 1 x minus 1 plus 1 over x plus 1 x minus 1. All right, there's my common denominator. Everything's a common denominator. All I have to do now is add my numerators. So let's do hippity hoppity distributive property. And I'm going to get 2x minus 2 plus 2x plus 1 plus 1 all over my common denominator of x minus 1, x plus 1. Combine like terms, and I have 4x, and that's it. Because I have 1 plus 1 is 2, minus 2 is 0, so that's 4x over x minus 1, x plus 1. And you're done. Not terribly bad. Not terribly bad. All right. Well, ain't nobody in the chat. I have 3 people on here. Anybody need help with math? Give you a little, let the stream catch up to me. Need help, need help, need help. Now's the time to ask. Type it in the chat. Nobody's asking questions. I'm just going to work one more problem and I'm going to end the stream. Due to lack of interest today. I figured it'd be pretty dead today and tomorrow. Most of you guys have turned in your packets already. So that's a good thing. Only body on here is really the folks that are procrastinating, which is, I don't know, half my students, 3/4 my students. Just nobody has questions. Nobody has questions. No questions. All right then. Let's have a little bit of fun then. Yeah, let's have some fun. Why not? I'm going to work this problem, and if nobody has any questions after that, I am going to shut the stream down. This is actually called a difference of quotient problem. Difference of quotient is actually how you hand calculate a derivative, but this is the algebra version of it, or the algebra part of it. This is actually where most people start struggling in calculus. It's just not because of the idea of the calculus, it's the idea of the algebra. So I'm going to write it like a calculus problem here, and it's going to say the limit as h approaches 0 of 1 over x plus h minus 4 minus, oh, I'm a little high up. Let me bring that down some. So 1 over x minus 4 plus h. It doesn't matter the way I wrote it. minus 1 over x minus 4 all over h. Okay, so the calculus part of this is actually pretty easy. This limit, what you're supposed to do with limits, or one way to evaluate limits, you just take this number and you plug it in, and I get a 0 here, and that's a problem. You can't have a 0 in the denominator. So what we need to do is we need to simplify this so we can actually evaluate with the 0. So let's take a look and see what happens. So I've got to work this top first, and this is a rational function of subtracting rational functions. And if you notice, they don't have a common denominator. So I need to make it have a common denominator. Let's see, what do I want to do with that? Got to multiply it out. Life sucks. All right, here we go. So I'm going to have x minus 4 over x minus 4 plus h times x minus 4, because I have to multiply my denominators together. And this is going to be minus x minus 4 plus h all over h. All right, that seems simple enough, right? Distribute and combine like terms. So I'm going to have an x minus x, so that goes away. Negative 4 plus 4, that goes away. So that gives me h. So that just gives me h on top. A negative h on top. All over x minus 4 plus h times x minus 4. And this is still over h. All right, well, this really means negative h over x minus 4 plus h times x minus 4, trying to avoid having to distribute this out, times 1 over h. My h is canceled, it gives me a 1. I'm going to have to distribute it out. Going to have to distribute it out. This gives me now a negative 1 over x minus 4 plus h, and then x minus 4. And let's FOIL this out. I got a negative 1 over, I've got an x squared minus 4x minus 4x plus 16 . No, I'm good. No, I was good. Yeah, we'll do this. We'll finish this out. Plus 16, and then plus x to the 8xh minus 4h. From here, combine like terms, I've got negative 1 over x squared minus 4 minus 8x plus 16. Plus xh minus 4h. At this point, I just plug the h in at 0, and I get that the limit as h approaches 0 on this one. Now, this was not a calculus problem. I just threw the limit on there just because. I don't want to do that. I don't want to do that. There's a reason why they didn't have that on there on the problem. Easy enough. This is the original problem in the book. This is the difference quotient right here. Because if you put 0 in for that, you just get negative 1 over x squared minus 8x plus 16. Not terribly bad. Not terribly bad. Nobody has any questions. Nobody has any questions. Well, I'm going to call it quits then, guys. If y'all don't have any questions, I'm going to call it quits. I'm going to try again. I'm going to try again tomorrow at 5 o'clock. Answer any questions. Hopefully, this is going to drag out. Hopefully you guys are doing the math and understanding it. Because if not, it could be really rough when we're finally back in the classroom. Could be really, really rough when we're back in the classroom. All right, I'm going to go ahead and just end the stream. And I will see y'all again tomorrow.